What's up? Hello. Hello, Random Bird. Hello, Warbles Workley. Things are doing really good. Here is the plan for today. Hopefully, these two things. So first of all, I want to do some power section docs for Timex so he can continue the work on the software side. And I want to start working on the PCB because, man, I've been waiting to do that for like too long. I really want to do it. It's been ages since I've done a proper PCB. Just need to... Just 1 second. Give me a second. Okay, I think we have the bot in chat. That is great, actually. That is so great. So now we have some commands. For example, we have the commands command. Should work. Yes! You guys don't know how much time I spent on that to work. For example, if you guys want my schedule, boom. It takes a while to respond though. But it works, okay. It's the most important. I like this idea. Did you know how you can create a secure ROM? The CM5 supports ARM Trust Zone, meaning you can make classic Android ROMs. For now, we are not really dealing in Android stuff. We're trying to get something related to, you know, more some modified Debian stuff. You had to set up the same thing on Rumble. Yeah, Stream Elements, I really appreciate that they like want to help or whatever, but the interface, especially for YouTube, is so complicated. Like, especially for multi-streaming. Welcome everyone who joined. Buongiorno. So I think in a couple of seconds we're going to start. I don't know, maybe some people will join and, you know. Linux is the way to go? Yes. I think so. The challenging part may be to make it intuitive for normies, you know, because one of the goals of the project, if we, oops, hello OBS, 1 second. 1 second. If we pull up the project goals, easy to use for non-technical people. So that can be the challenging part, I guess, with Linux. Know what I mean? I think it's solvable. You know, I'm an optimist, okay? So maybe, guys, I'm gonna show you what I have in terms of docs. Right, if it's going to get boring, I'm just gonna skip straight to the PCB. So, Timek is working on the operating system side of things. And he requested me to compile a document that would make it easier to understand the power section schematic, which is a little bit complex. It's a little bit on the complex side. I will admit. It's beautiful, but it's complicated, okay? Let's send this to desktop 5 and this desktop 3. Okay, so this is the power section. It is a little bit complicated. I get it. So I decided to document it just like it is documented. It is laid down here. So each section, each rectangle will have its own paragraph in the document. Makes sense in my opinion. Also, he requested me to list all of the pins or functions that talk to the software. For example, the sys pin, the stat pin pulses and lets know to the system, to the software, if everything's fine with the charger integrated circuit. There are some other pins that just communicate something to the computer, but there are also others that just control the hardware. For example, the EN pins here. EN stands for enable. So the point here is that these labels go here. They will be connected to GPIO pins, and pulling them high or low will be equivalent to enabling or disabling these three DC to DC regulators or converters. Converters is the word, I think. Get it? Pretty simple, I think. The documentation side of things. So I already wrote the charger part of things. I don't really want to, write the same stuff over and over again that's already available in the data sheet. So maybe let's continue with the 3.3 volt rail. Let's see how that goes. I'm gonna send this to desktop 5 and split screen it. So on the right side I have KiCad, and on the left side I have Obsidian with Vim motions. Looks like the GPIO turns on off 1.8 and 3.3 volts. Exactly. That's exactly what's happening. Here's the 1.8 and here are the two 3.3 volt lines. We have two of them. So DC-DC 1 enables L1. L stands for inductor because the inductor is here. It doesn't enable the inductor, I hope you know what I mean. It just enables the converter, right? Inductor is just a passive component, just sits there, right? So, quick description of what the TPS 650250 is. So I could think of one, but instead of being original, I'm just going to go to the datasheet directly. Probably copy the first line. The TPS device is an integrated power management IC for applications requiring multiple power rails. Got him. I think that's fine. You know what? I'm gonna take this. Let's put it here. Integrated power management IC for applications. Maybe let's simplify this. Integrated power management IC that provides multiple power rails. The TPS, one second. What if I enable compositor on my system? So I have window transparency. And what if I just, okay. I thought I would be able to see the, hello, Mr. John Diode. I thought I would be able to see the schematic below the text if I go like this, but it's not the case. But whatever. Whatever. Right. Also, I forgot to enable screen key, I think. Okay, so now you can see the shortcuts I'm pressing, all of the keys I'm pressing. That's cool, right? Multiple power rails. I think that's a little bit too much text here. No point in just repeating the data sheet, right? Okay, so let's start by the pins. Let's talk about the pins that are the most important or that talk to the software. So mode is controlled through hardware. We don't have any option to change it right now with software because it's hardwired to ground. You cannot pull it up. Same goes for the LDO and... oh no, actually no. We are not using the LDOs. Are used. We only use the free DC-DC converters. The two LDOs are not in use. Currently, or okay, let's start by EN DC-DC1 through 3. I'm just gonna copy this, I think. Let's go to here. So yeah. Would you call that a regulator or something else? For sure it's not a transformer, because transformers are only for AC, am I right? So I think that's a regulator or converter. Maybe it doesn't matter. Anyone knows? I'm gonna guess converter, because it's a boost converter or something, I think. Fine, we got this. I forgot what this does, to be honest. I think it sets the voltage. Yeah, I think it's this. Yeah, defines the DC-DC converter voltage or regulator. Converter. Nice. So next we have the power fail. You can use the phrase buck boost converter. Okay, good. I also thought it was a converter. However, I don't know what's the difference between a converter and a regulator. Okay, I know. Just kidding, I know. I think regulators are simpler devices, like 3-pin type devices that maintain a constant voltage, I think. But I don't know, man. I don't know how I would define it. I could ask Perplexity, but I don't want to. Converter equals active. Diodes Incorporated, the favorite company of John Diode. Maybe he's the founder of it. I think we should ignore this for now, just to maintain momentum, as management would say, probably. Okay, so power fail. I'm just gonna document the first section, this section, and go on to playing with the PCB, I think. Because I just cannot wait. I'm impatient. Power fail. Alright, so alerts the system when battery is low. Let's put this. No. That moment when neovim is just too hard. Yeah. Nice. So this is the power fail, and what else talks to the computer? I think that's it. That was just too easy, man. I should never say that, by the way. So this divider here sets the low voltage threshold. I think I set it to 3.2 volts. That's quite conservative, I think. One thing that I'm noticing is that I have no idea how will the computer know if what percentage, what exact voltage the battery is. Google says a regulator is used when you need a stable power rail, a converter when it's not necessary. So, okay, regulator is for stable scenarios. Okay. Got it. Okay, I think we're done with this. I mean, we're not using some of the functions, so that was easy. Here are the labels from the power schematic. Maybe I could... I set myself a custom shortcut to make a rectangle. Now I forgot it. Super nice. It's Control R. Come on. Just for documentation's sake, so people aren't even more confused. Yo, hello. Only smaller for low power, high power applications require more size. Okay, that's referring to something else. Hello, Vragtekken. I've long time no hear from you. I think you're one of the first contributors, actually. Alright, so... power section labels. Got him. Right, we are finished with this. I kind of want to do another section here because that was just so easy. I thought it was going to be boring, to be honest. Maybe I'm gonna mention these rails we have here. The 3.3 volt A rail is reserved for the power-hungry EG25 GSM and GPS IC. My guy, what specimen does that microphone belong to? It belongs to DJI. Unfortunately, I'm not proud of that. I think they're not a good company, like from what I heard. You know, making your own microphone is something that I am really interested in. But if I think to myself, push the smartphone forward or make the microphone, or, you know, branch off to some weird side projects, then, you know, it's probably better for humanity to, most importantly, for me to focus on one thing. Maybe. Not sure though. One could counter that quite easily. I'm not gonna have a monologue on that right now. But I could go on, like, for example, maybe it's better to do a couple of small projects to not get burned out, you know? Or use your current smartphone as a microphone. Also, what phone do you have right now? I have a Samsung S10, which is a good phone, but I don't think Samsung is a good company either. I have been looking for some interesting, like, concept phones yesterday. And I have some stuff to show you guys. Not now, not now. Using a phone as a microphone is not a good option. Just the quality is just too low. In fact, I was thinking about getting a better microphone. I mean, this one is probably fine because you guys probably are fine with this. This is probably good, but I was thinking about getting something better even. But sometimes you get into the illusion of getting better and better gear, and you know, no one notices the difference in reality, right? So sometimes people just, I mean, like content creators stress over audio quality and so on, and sometimes it's important, sometimes it's not important. I think it's important to be able to judge that, you know. For example, let's say you're Michael Reeves. If you have a section of the video which is super loud and noisy and we can barely hear him, that is fine because his style is like that. It's like chaotic and stuff. But if you're, I don't know, Veritasium, which has like an entire production team and everything, and is like a professional science show or something, which aims for highest, you know, production quality possible, you know, microphones and shit, then probably it makes sense to upgrade as much as possible. Whatever works, you know, just throw stuff at the wall and see what works. Hello, Ginger. I think I should bold this so it's more readable. This could even be a table, you know, but I don't want to complicate stuff too much. And this is also subject to change. Crazy Polish man does electrical engineering. Yeah. Fucking love that guy, Michael, man. I don't know how he's so smart and manages to hide it so well. That's the thing. Most people are stupid and try to appear smart, but he's reverse. He's smart and tries to appear stupid. Do you guys agree? I think, you know, that's the unique thing about him. That makes him relatable also, because, you know, there's 1 million other YouTubers who try to appear smart and, you know, intelligent. He just doesn't give a shit. Maybe he is actually. Maybe he's not pretending. Yeah, exactly. He's a deep person, but tries to look like a goldfish 24/7. Also, he's a content beast. Like, he can make content out of anything. It's like a superpower. Okay, now 1.8 volts. 80% of Twitch streamers abuse smartness. I don't know, man. Twitch, to me, I have a very harsh opinion on Twitch. Like the amount of stupid, dumb things that there are there. Like, even if we consider video games not stupid, you know, then all of that stuff there. Yeah, do your Python tutorial, man. Thank you for hitting like. Also, you all guys should hit like on the stream. Would be nice. How is the project going? Very nice. Right now, and maybe I should do a summary of what happened last stream. For anyone that missed it, the big achievement was writing a Python script on stream without like, with a library that this was the first time that I saw it, and somehow I managed it. Granted, it's quite easy, you know. I think it's this, yeah. This disables all components except from the power schematic. And you know why I did that? I did that because I want to test the power schematic on a real PCB. So that's the point of deleting all of this. I mean, not deleting, just setting to do not populate. If someone doesn't know what I mean, this, if something is crossed out, it means it won't be populated on the PCB in theory. I don't know if the manufacturer will get that, get the memo, you know? But I'm gonna make sure they know, you know, just to not waste money and resources. Let's give an example. Let's say camera, maybe? What voltage is the camera? 3.3. Let's give an example here as well, and that would be probably the screen. Maybe even only the screen. This is a lie. I sent an email to the manufacturer. Nice project. Will you be using HDLS like system Verilog? Sorry, I don't know what that is at the moment. I'm not gonna pretend, I just don't know. Right, so I think for now 1.8 volts is only used here, nowhere else. So let's say screen. What else can I say? Yeah, I sent an email to the manufacturer, which is NXP or Rockchip or Rockwell, I don't know, asking them about their crazy ass data sheet, which doesn't even let you know what's the power consumption. It's TBD. That's a red flag that I didn't see earlier. Apart from that, where's the pinout? Yeah, here are the pins. So here's a 3.3, fine, normal voltage. 1.8, fine, typical normal voltage. 2.8? .8 volts for what? I don't know why it's 2.8. Maybe it's an optional pin that you can either use VDD or this VDD. Anyways, I don't want to guess because this screen is like $100 almost. So I emailed them. Also, I emailed them asking for drivers. So if they don't respond, we're going to have a big problem. And I know you guys don't like the current screen. I also don't like it. Maybe we're going to have to change it. I get asked every 5 minutes to change it, by the way. We're already streaming for half an hour and I just wrote some text. I need to, okay. That's enough for now. Later I'm going to document the rest of it, or maybe next stream, I don't know. Documenting stuff in theory is boring, but in reality, it's good because it lets you catch some problems. For example, I didn't know there was this 2.8 volts weird thing. The electronics, have you looked at the screens from WaveShare? I don't remember, honestly. I looked at so many screens that I don't remember if I looked at these specifically. Could you please send them on Discord? Okay, it's time to close the text editor. And let's try to do some progress on the PCB. Let's just try, okay? Okay, I like to have, like, if someone never used KiCad, if someone never used KiCad, if you press the footprint here, it jumps to it in the schematic, so that's very useful. I have a question recently, have been fascinated by the core boot, which is basically has a Linux bootloader, and Libre has even more open source, so could the Spirit smartphone support that? Support what, to be honest? It's like, what specifically? I don't know, man. I don't know. I'm not focusing on the software right now, so it's a hard question at the moment. So I should probably start by grouping them. For example, all of the resistors and capacitors related to BQ should be close to the BQ. I think that would make sense. I'm also interested, what is the maximum current of the BQ? 5 amps, so that's a problem. That is a problem, I think. Not sure though. It's a problem if the CM5 runs at full speed, like 100% load, and the EG25 runs at 100% load, then we have a problem. Because then we would get probably 6-7 amps. That would be a problem, but worst case scenario is that it would just shut down and nothing wrong would happen because it has thermal protection. So I think it's worth testing, because if that problem occurs, an easy fix would be just to underclock the CM5, for example. Or use some sort of underclocking or low voltage mode on the EG25, which probably has something like that. I don't know though. This is weird. This should be U4, not this. I'll just change it by hand for now and not worry about it. That's weird though. Okay, so resistors 4. I'm trying to see the numbering pattern here. 4 and 7. Oh, and also we have to decide on the layers. We also need to take care of that. Because I didn't decide what the layers should be. And I don't know if it's even possible to decide right now. Like, maybe I should start off with 4 layers of the PCB, see if it works that way, and in case there's a problem, add layers. Up to 8. That's what I discussed with the manufacturer. So I think that would be the best approach. If we can fit in 4 layers, I think that would be a massive W. Massive W. And also I want to change the grid to like 0.5 millimeter. Maybe even 1 millimeter. Nah, half. Do we have any people on Twitch? If you are watching from Twitch, hello. It's been a while we didn't get any Twitch bot. You know, just appear and advertise some random shit. This is super small. Probably, like, I don't know, part of me wants to go with 0402 footprints. I'm interested to see which one is a sys. Where is sys? Doesn't exist? What? Okay, that's a problem, chat. That's a big problem. Okay, this is in a via. That's crazy, no? Where's the switch? I don't see it. It looks like this is missing. Looks like this is just missing fucking pins. Am I an electrical engineer? Nope. I mean, I don't have the degree, right? If you define it by degree, I don't have a degree. So, what if I just remove this and try to re-import it with F8? No errors related to U4. Oh, here are some errors related to U4. Right, so we have, for some reason, that's the wrong footprint. You guys are funny. Right, so maybe easiest fix would be to try and just get the correct one from, I don't know, DigiKey, let's say. But that's really weird because I get all of these footprints from there, so that's weird. Maybe I can, 1 second, I can also check the recommended mounting and see if the dimensions or something, layout. Isn't there like footprint information? Only layout? Also, I'm kind of breaking the rules because I'm using... Some of the capacitors are bigger than that. That's the package size, of course. Okay, I should really look at this, of course, when designing this. I didn't read that yet. I don't see footprint stuff, like dimensions. Maybe it's a standardized package. "29 pins. So let's yeah, that's not 29 pins for sure. That's 17 pins. Oh, 21, 22 pins. Right. I didn't want to do that. If this is a problem with the G key, I'm just gonna report it. That would be the second problem I found on their website. I'm the biggest nerd. So this symbol is much different. So I don't know where I got this from. Crazy. Do we have a 3D model of that thing? We have, so something must have gone horribly wrong in my brain. Or maybe someone else did that somehow, like a contributor, I don't know. Mr. Nima, maybe? Whatever. I don't know, do you have a name, I mean, do you have this expression in English that there's no point in crying over spilled milk? Do you have this expression in English or not? I'm just curious. Yeah, let's take those. Let's see. I don't know, in Portuguese there is though. Okay. By the way, your name is beautiful. Like it reads like some sort of like poetry, or I don't know. Let's get some music. Let's get some jazz. Yeah. Hello from Indonesia. Hello. Unzipped. So we have the step and we have the mod. Okay. I'm not gonna delete the symbol for now in case there's any other problems that I discover. We have two step files for some reason. I don't know, man. Two, 5, 7, 9, 2 RQMR charger. Didn't save. You know you're on the right path when something in the circuit catches on fire? Nah. Hello, Mr. Terran Earthling. How are you doing? I'm just gonna say charger at this point. Actually not. 5792. Psych. Got him. So model goes here. We did that 1,000,000 times. I'm not gonna go over this. Nice. Maybe just for people who don't know, I'll rename this to charger. Got him. Great. Now let's symbol editor. Let's set a goal. Let's set a goal of, Laying a couple of useful traces. That's a fair, reasonable goal for this stream, I think. Like PCB traces. Is that Yazzie? No, that is Ranger, but Yazzie has been recommended to me. I did not try it yet. So that's the wrong... What? Wait. That's not my thing. I almost got tricked here. It's not the wrong it's the wrong symbol. This also is wrong. This is default library. Right, so now we are uncovering a problem. It's in a separate library called BQ something something. Hell no. You know what? Fastest way to solve this is probably to do just... That's weird. Look. This has 29 pins. Okay, check this out. This has 29 pins. Now I go edit library symbol. And this is empty. Looks like the person who imported it didn't add it to our library of symbols. I'm not gonna fix it now. I'm just gonna change the footprint. Look, it's a different footprint. Some RTE0, I don't know. So that's the problem. This is the one. Okay. Before we refresh this. Pranked again? Yeah, that's like, I'm used to being pranked. I mean, it's kind of my fault because I was reviewing all. Like, I don't know if someone did this change. It probably went through me because I'm reviewing stuff. Like contributions, so I can only blame me, Mario, okay? '3D model. Oops, here, this. I hope KiCad 10 automates this. I hope so much. Okay, we got this. To be fair, this would be the work of a whole team of people. Really? Like, I have no experience in professional electronics work, so would that be a team of people? Or would one person do one schematic, one person the other, etc.? I mean, maybe... I mean, actually, it is kind of the work of multiple people, because whenever I have a problem, I ask people. So I can delete this piece of shit. This should be updated. Yes. F8 now. Any second now. Okay, no U4 problems. As far as I can see. U3 problems, U5 problems, sure. But No U4 problems. Hello, Mr. Joseph. What is on the address of 0x45? What's that address? I mean, I'm not a truly fledged electrical engineer either yet. Okay, are you studying or are you self-teaching yourself or what? What is going on? By the way, today was the first day of university, like in this academic year for me. It's funny to see those people again, like just funny. I already learned some interesting stuff. I don't want to get too sidetracked though. But yeah, I cannot help myself. You guys know gears? You guys know gears? Imagine a gear. How do you manufacture gears? Maybe on a CNC mill, right? But what do you do to them so that the teeth don't break off or wear out too early? What do you do? Any guesses? Small hint. It involves gas. Lube is one thing. I mean, probably like grease, machine grease or oil or stuff like that. Or even just sometimes the mechanism is just drenched in oil. It floats in it. But you heat treat it, okay? To harden the teeth. But you only want to harden the surface of the teeth. Of the tooth. Sorry, English language. Stupido. So how do you do that? You cannot put it in an oven because you would heat up the entire thing, and you don't want that because heat-treated metal becomes harder, but it's also more brittle. So you only want the surface of the teeth to be hardened. So you, for example, could use a torch. In this cool process that or something like that. I'm not really sure what's going on, to be honest. Anyways, the goal, this looks like induction heating, I think. Just notice that only the teeth, the surface of the teeth is being heat treated. So that's a little thing I learned today, just sitting and listening to Professor. That's really a random piece of information, but I guess it's useful for me. Maybe someday. So that's not what you want to do, I think. I don't know. I don't know. Usually you have a process that automates this with machines, torches, or whatever. Let's get back to electronics, okay? Also, I had a funny situation. I had 2 lectures today. One lecture, the guy told us, what material would you use for something? And some people said aluminium, which is normal thing to say. Like, aluminium is aluminium, fine. We make phones out of aluminium and stuff. But he's like, engineers don't use aluminium. Engineers use aluminium alloys. I was like, bruh. And all my friends were like, bruh, like, of course. Why didn't we say aluminium alloys? Like, of course you mean aluminium alloys. And he said raw aluminium doesn't have any use cases because it's just raw aluminium. It's not processed. It doesn't work like aluminium. And then guess what? The next lecture, different professor, he just goes on saying, we're making stuff out of aluminium. Aluminium, man, just aluminium. Like, there was such an actually moment. It was funny. Vibranium. Obamium. Guys, I recently talked to the President of the United States. He told me you should subscribe and like the stream. Aluminium alloys versus aluminium is such a distinction about a difference. Yeah, like, because everyone means alloys. Let me catch up with chat for a second. Mr. Bernardo, I'm second year electronics engineer student, personally doing internships too, but where I live, my work is related to cars. Cool. Would you perhaps like to contribute to Spirit Smartphone? That would be amazing for the project and very cool in my opinion. If you want to contribute, just any day, man, any day. I need help, for example, double checking this schematic. That's a big thing I'm asking people to do now because I want to test it as soon as possible. Later it's going to be expensive to make these mistakes, right? Just got a call from the White House to like the stream. Yeah, like, man, I have contacts, you know? I have contacts. Many people call me to tell you important stuff. For example, Louis Rossman told me yesterday, you should take a look at my Patreon. Maybe you'll find it interesting. Right, I got distracted again. What's the time here? And what's the time of the stream? 1 hour. Okay. First year would love to contribute, but I don't know even where to start. Okay, so first of all, join our Discord and let us know what's your area of expertise. Like, what do you feel most interested in and what's your best skills? For example, is it electronics? Is it CAD design? I mean, CAD modeling? Or maybe is it PCB design? I don't know. Whatever, maybe it's operating system development or just C++ in general. Or just C, I don't know. Maybe Linux stuff, maybe, I don't know. All of these things would be useful and many more. So to anyone watching who would like to contribute, join our Discord and just introduce yourself. Like, my name is Jerry and I like 22-volt rails. That would be very useful. Anyways, let's vibe check this thing. Ben 29, beautiful, tremendous. Okay. Now I'm interested to see if the footprint follows some sort of pattern in relation to the symbol, or is it just all over the place? I think it's just all over the place. Okay. What if I do Shift X? Oh, we'll check this out. Okay, but first layers. I like 22-volt rails like I like my women. That's a good pickup line. Mr. John Diode, Is there a way to make contributions? Yeah, first get in touch with us and also read the contribution guide available on GitHub main page. Just click the contribution guide button or something. You should have an entire document, you know, to get a feel for the process. It's really simple actually. You just download the version of the project from GitHub using Git. You make a change before we discuss, of course, what change you make. Then you make the change and you submit it for review, and me or some other person, probably me though, because I like working for free, will check your work, and if it's fine, it's going to get accepted. If it's not fine, it needs some fixes, and later it's going to be accepted. Or maybe it's totally wrong and it's never accepted as well, but I think that happened only once. I don't even remember the actual problem. All right. I forgot how I switch layers. Probably here, right? Yeah, so right now I set it to have 6 layers. They are here. The colors are cool, I like them. That's important, right? Pushing them, don't send them directly to Git. Yeah, like random people who download the project don't have the possibility to modify the main project, right? That would be a disaster. Only people with right access, meaning me, have the possibility to accept changes. Read up on something called pull requests, GitHub. Connect a few electrolytic caps backwards for a nice fireworks show. Bruh. Like, should I stay with 6 layers or should I just start off with 4? Here's the stack up, so the layer settings. If you can give any feedback, that would be appreciated. So my initial idea was to have 6 layers, as I said. I don't think I assigned like functions to them. Let's open, let's close, oops, fuck. Oh, I think I just closed my stream. I only closed my music, so that's okay. Let me fix that real quick. I thought I just, ay. You hear me, right? Chat, you hear me, right? For a complex design like that, 6+ layers is usually preferred. Yeah, that makes things easier, doesn't it? Like, trying to smash everything into 4 layers would probably be very frustrating. Though 4 would be cheaper. Exactly, that's my thought process here. I wanna go to... Let's have a think. Let's have a think here. I'm gonna say... Maybe there is typical 6-layer PCB stack up or motherboard. Yeah. It's better to start with more layers than do revisions to fit in 4. Okay. A minimum viable product, if you will. Okay. I agree with that. So let's say 6. Let's 6 layers. Can I insert a table? Table. Oh, maybe not. Oh yeah. That's what happens when your neovim config is just too complicated. You get it barely working, then refine the final product. Yeah, of course. Yeah, let's not do a table then. Let's say top, bottom. I'm thinking, I don't know. This is AI generated, right? I hate that, actually. I hate that. It's fucking... My question is, should the signal layer be between... should it be on the outside, or... I don't know. Yeah, that's what I wanted to do. Dedicate an entire layer to power and have like regions or something. I don't know what a core is. I should probably read that before the next stream, right? Take this, put it here. Do you have a clean tip? Solder tip, right? Hello, you're designing a phone, that's cool. Yes, exactly, I'm designing a phone and I also think that's really cool. My main concern here was to know the function of the layers. Here they just... I also know that obviously, you know, it would be better to not have power lines inside of the PCB because power lines have to be thicker. My 100 seconds videos are great, thank you. Yeah, high-speed signals should be between ground or maybe between power to have like, I don't know if you can call it the Faraday cage effect or something, to have less emissions. So let's say, let's number them first of all. Let's say top would be I'm gonna say power, signal, ground, signal, And maybe we could just end it like that. But then we have... Oh, I have an idea. What if we do high speed signals here? Because I think they're the ones that do the emissions. And low speed signals here. What do we think, chat? That's 4 layers, not 6, of course. But if I had to do 6, I would do probably... I didn't know you can reset the list like that, by the way. That's pretty cool. Just R1 fucking resets the list. Isn't that incredible? So maybe now I would do something like power... whatever signals, like... signal... It didn't reset it? Come on, man, come on. Oh, it doesn't work. Oh, because they're touching. Are there PCB experts in the chat? Probably there are, but not everyone wants to, you know, talk. There are some lurkers, some people who just watch. They're like not chatting, you know. Power signal, ground signal, and then another ground. Or power, whatever. Actually, no. You're a tip expert? That's kind of sus. It's kind of sussy. Maybe there shouldn't be power on the outside, because if someone puts the PCB on a metal table, or it touches the metal chassis of the phone, then it's basically shorted out and it's a problem. So maybe it would be better to have grounds on the outside. Makes sense? Makes sense. I don't know if that makes sense. I would ask Perplexity, but I don't want to. So maybe, yeah, I know, ground. No, do I need this many grounds? Probably, yeah, probably. High speed signals. Ground should sandwich high speed power. I think power can also be the sandwich, you know. Like signal is the I don't know how you call the contents of the sandwich. I don't know, the cheese. Signals is the cheese, and ground and power can be the bread, if you know like what I mean. That kind of sandwich I think makes sense. Of course, ground is the optimal bread, but you know, power can also be bread. I think that's just what I think. No real arguments for that. Ground signal, ground signal. All right, so this I would like to be power. Like that, and this should be ground. Nah, stupid. Power is usually shallow, but not too shallow. Why? Why is that? Is it because of like heating issues? You know what? What if we had a layer specifically designed for debugging? I don't know. No, we need at least 2 signal layers. That's stupid. Okay, I know what I wanted to do. I remember now. Let's do... heating, exactly. So power is the second layer, that's fine. Power next to ground isn't like a capacitor. And no. Thickness isn't the same. Like you can set the thickness in the CAD program. And from what I know, the outer layers can be less thick than the inner ones because of heat. Capacitor. Hello, man. That's a beautiful name. Like, is that your real name? Right. Is it forming a capacitor? Like, probably. Probably, like, if you think about it, everything is a capacitor. Like, people are conductive, right? If 2 people talk to each other and are, I don't know, 1 meter apart, it's like a capacitor. Because the people are conductive surfaces, there's a gap between them, and we have voltage and electricity inside of us. You know? So, like, everything is a capacitor. Just the problem is sometimes the capacitor is just too capacitory. So that's, I think, parasitic capacitance, is that it? Is that the term for that? When parts of the circuit act as capacitors when you don't want them to? Maybe that's it? You're a diode? Man, that's crazy. What's your favorite component, guys? Honestly, like, be honest now. Be honest. Like, okay, almost. Okay, I got distracted. I think this makes sense. Makes sense? High-speed signals are sandwiched. And low-speed signals are kind of sandwiched because they're not a problem, I think. Resistor. MOSFET. Audio component. But what audio component specifically? Think you're right about everything is a cap. I've read we should not put them together, but all PCBs seem to stack or cross them on the same layer. Like, sometimes it doesn't matter when you don't need any precision or, you know, some noise is acceptable. Transistor, MOSFET, okay. N-channel or P-channel is better, in your opinion? The protector. Okay. Fuse, F-Fuse. That's another beautiful name. You guys are so talented. Dolby Atmos. Okay, that's fine. N-channel. Okay, I also prefer N-channel because it's just the normal way to do stuff, right? Who uses P-channel? Should high-speed signal be close as possible to their connection? Yeah. There should be. Like, they should have, I mean, it depends, right? Because in USB, you need to control the impedance of the line. That's why sometimes on PCBs you have these squiggly lines. Then they are there to make the trace longer on purpose, to change the impedance, because length impacts impedance. There are calculators for that. I don't remember the formula and stuff. Can I go with varistor? That's a good one. I think recently I understood what a variac is. It's a really cool thing, man. Including high-speed power signal from the converter. Transistors because they're smarter than me. Via affect the signal? Yeah, I don't know, man. I don't know. I think for the signal, it's best to have a... It depends if you need to control the impedance or not, in my opinion. That's everything I can say. If you don't have to, the shortest is the best. If you don't have to control the impedance. But if you have to, then it depends what impedance you need, right? Because shorter lines accept less noise from the surroundings, am I right? Talk nice to it, then it will work. Bruh. Then I'm gonna have to talk a lot, you know, to my to my design. Okay, so I think we decided this makes sense. The Audi. What's up with you guys? Do you like change your usernames? Did you change your username right now to electrical components? You guys are very smart, intelligent, and talented. Just wanted to say that. Okay, let's maybe rename these if that's possible. So we have the layers invented. Can I change their names? They are all here to make me make the phone. Be sure to completely isolate the rails. Yeah, of course I need to isolate the rails. Like, I cannot short them. That would be a big no-no. So I cannot set a name here. I can set the name here though. So let's say this is front. CU is copper, of course. I wanted to ask you guys, what is your favorite like periodic table element except from copper? I'm just afraid to ask at this point. Right, so let's start with ground. I don't know if that makes sense. I think it does. I think it's easy to change it later. Because you can just swap the layers, probably. Is that true? If I make a mistake and, you know, I want to change the layer structure, can I just, you know, swap them easily? Come on. Like, I could probably ask Perplexity, but I don't want to. Let's have a little test. Let's say how do I exit this? Oh. Okay, thank you. Let's say I put a trace on the top copper layer, right? And now I want to put a trace on bottom. I mean inner one copper layer. Don't know about swapping because I only done it in my unworking OBD2. I don't know what's OBD, but I'm guessing I can just highlight it, Control X, go to the layer I want and just paste it. Okay, but it didn't paste it like I wanted. Interesting. Let's try to search. Reorder KiCad layers. Is it possible? It's a combination of reasons esoteric and personal to me. When ancient spells EEV blog. It's the human in me. Is that the man? Bob's your uncle? Did he ask that question? KiCad 5 has edit, move, and swap layers. He didn't say where. Oh, okay, okay, check this out, check this out, check this out. Check this shit out. Dave Jones is the best, man. Like, I fucking love this guy. I would like to send the smartphone to him one day. Would be beautiful. Swap layers. We got it. Do it in the mailbag. Yeah, that's what I wanted to do. Just send it to him. Write a little letter. Say, my name is Jan. I made a smartphone. Please review smartphone. Thank you. Cheers. Hello, Bodger's Bits. Send it to his mailbag. You got it, man. Also, guess who I wanted to send it to as well? None other than Louis Rossman. Imagine that. I think he would explode from happiness. I know I would if I saw him. You know, if he's happy, then I'm happy. Yeah, everyone just, we learned something here. How to switch layers. Edit. Swap layers. Put a clippy wallpaper on the smartphone. Good idea, good idea. I don't know who is Big Clive. Could you send a link in the comment section or on Discord? Maybe in the comment section to boost algorithm. Yeah, so I can just... Okay, let's try to swap. Let's remember, right is green. Right is green. Move items on red to... Okay, let's maybe do this. There's a kid screaming. I hope he's going to shut the fuck up for a second. I don't know how that works though, to be honest. How does that work? I don't know, I think I'm gonna ignore it for now. Makes sense? No, let's ignore that. Let's ignore that, but I want to rename the layers, just so it makes sense. Was it... I forgot where... oops, I pressed a random button. Board setup. Okay, front copper is ground. And ground counts as power. Then we have power. And power is power. You guys knew that? Signals. These are the slow signals, right? Yeah. Slow signals. Ground. Okay. This is power. This is, I'm gonna say high signals. Makes sense. I'm gonna say ground. And I think that should rename them here. Yeah, that's perfect. Perfect. I am happiness. I gotta let my puppy out, she whining. Honestly, I don't understand people who have dogs. I don't have nothing against these people. I just don't understand. Like, I fully respect you, but I don't understand you. I don't understand the decision, right? I mean, the only argument people usually have is that they're cute. Dogs are cute. Same goes for other animals, by the way. Maybe that's controversial. Maybe that's controversial, but I think place of animals is in nature. Not in your house. And now don't hit me with the argument that but a dog or hamster would not survive in the forest. That's because you've been feeding them weird people food the past 2000 years, and now they have become so deformed that they cannot even hunt usually. All right. Let's lay some traces. Let's follow our goal here. Just wanted to double check if I can just do stuff like that. Oops. If I can just... Hello. That's really fun. Imagine producing a PCB with this kind of mistake. He hates us all. That's absolutely not true. I love you guys. Don't listen to the misinformation. Right, imagine if I produced the board with this and would just spend 100 hours troubleshooting. Was the problem just fucking this would be the problem. Like, I don't get what's the issue here. Is it That the trace is too fat? Or maybe the grid? What are these green things? Maybe I was on the wrong layer? Okay, now it works for some reason. Hello, Peter! Hello. I responded to you. So why is this red? Because it's minus and it's ground. Okay, whatever. What if I'm trying to see if it switches layers automatically. Okay, let's do SDA because that's a signal line from the I2C protocol. What is going on? The routing, okay, the routing start point violates design rules checker. Maybe because it's not on the board. Let's put it wherever for now. What if I try now? Hello? No error message, but it still doesn't work. Crazy. Let's bring these two resistors for now. Let's put them here. Trace width, yeah, that's what I'm thinking, but I'm not sure. Now I'm confused why there's no error message. This is red as well. Right, where do I change the trace width? Do we have to put the via for the line? No. Okay, I don't see that immediately. I have to Google it. No answer. Anyone knows? Anyone knows? Where do I change the width? Design rules, predefined sizes. It's in board setup, right? Hi, of course I remember you, Mr. Rohit. Hello. I plan to make the update video whenever the power section PCB is produced. And that's kind of soon. Predefined sizes. Okay. I think it's here. So what is a reasonable... The lower you go, the more expensive it is. Let's say like 1 millimeter is kind of thick, is it not? Let's say I go with 1 millimeter. And then let's say I go with 0.5 millimeter. Just to test, okay? Don't scream at me, okay? Violates DRC. Okay, now how do I select the lower? Oh, hello, we have someone on Twitch. Thank you. Right click on the track and then properties. It should suggest 10 mils or 0.25 to start with. Okay, but isn't there like a shortcut or something to switch it fast? I don't see properties. Oh, I see. Okay. Okay, right. So that's 0.25. Okay, and here I have the sizes I defined. Thank you. Thank you so much. I'll define more sizes then. Not page settings. 1 second here. I need a second. Board setup. Predefined sizes. So for sure I want 0.25 because that's the default. And let's say I want 0.1.5. I mean 0.15. Makes sense. Let's see if it throws the error now. Let's say, okay. I'm just testing, okay? We're learning here. It's a learning experience. Let's set it to this. And now it's like that. Okay. So now, will the next one... Okay, the next one is thick. So how do I... Is it here? Yeah, I think so. I can just change it. Yeah, got it. I got it. I can just change it here. 0 millimeter traces. Makes sense. Nice. Is there a shortcut to change them though? Would be useful. But that's not... That's a big trace. I know. That's the wrong size though. Check this out. I have set this to 0.15, and if I inspect this, it's 0.2. What the fuck is going on? Like, if I have to modify this by hand, that's not a good thing. What if I just restart it? I know that's stupid probably. Let's just, you know, easy solution potentially. And let's try now. So this is net class width. 0.25. What if I want to do 0.15? Maybe there's a design rules checker or something. I recall when you set that width, then rerouting it will put the same width you selected. But it's not doing it. What if I go 0? Yeah, it still doesn't work. But if I go 0.5, it gets thicker. So it doesn't want to go below 0.25 for some reason. Maybe that's because of DRC rules. That's my second guess. That's my second guess. Board setup. Constraints. Okay, this is 0.2, so that should be fine. However, let's change it. Import the clearance from manufacturer first. For sure, there's oh my god! For sure, they support these sizes because they're pretty standard. It's not like super high precision. I like the music. It works now for some reason? That doesn't make any sense to me. Or am I blind? It works. Anyone understands why that works now? Like, okay, I think I know why. Because I just... Okay, I'm stupid. It was the DRC, by the way. It was set to 0.2 and I was trying to do 0.15. So we fixed it. Let's go. Now let's see if it will let me route to this little tiny pin here. Let's try this. It works! I feel so good now. Nothing stands in my way now. Nothing. Nothing. Very good. Sometimes the radius is not possible within the rule, and Hossein Ahmadi is right, yes. This was fun. Good luck with your PCB. Thank you. I hope you come back someday to my stream, because I'm trying to grow on Twitch. I have a massive presence on YouTube. A massive, like, for my standards, it's massive. But on Twitch, it's so hard to get through. I don't know. See you. Thank you. Thank you for joining us. Let's before I start, let's see their recommendations for the layout, I mean. Yeah, all of these points probably tell me that the smaller capacitors, the smaller value capacitors should be as close as possible to the pins and grounds. Okay, so this is weird. The connection from sys to 1 microfarad, 0.1 microfarad has to be routed on the top layer of the PCB. Why? Has to be routed on the top layer of the PCB. The returning back to ground also has to be in the top layer. What? Keep the whole routing loop as small as possible? Why do they care about the layer, chat? Anyone, any ideas? Why would they care about putting the trace on a specific layer? Ground loop? What do you mean? Hello, non-subham. You are, I wouldn't say you're late, but we're 2 hours into the thing, so maybe that counts as late-ish. But anyways, it's nice you're here. Like, thank you for joining me in this adventure. The returning to have the less noise possible. Yeah, but the thing is, the sys pin is just a power line, so I don't think it's a problem if it's a little bit noisy, because it goes into the regulators either ways. So that's what I'm wondering about. VBus is also just power, which is going to be regulated. So this data sheet is for the charger, and I'm trying to start off at least routing in the PCB here. And I'm wondering, why the hell do they require this to be on the top layer? Because that kind of messes up my plans of having the top layer as ground. You know? It's not a buck converter. It's a charger. It works with the battery too, so it's, you know, it charges the battery, okay? Takes power and charges the battery. Maybe let's just start from point number 1. I want to copy this and see the image. Here. For testing, okay, that makes sense. That makes sense, actually. But you could just have a via, right? And just probe the via with the multimeter or oscilloscope or whatever. So maybe I need to ask my professor Professor, why trays need to be on top? Mamma mia. And he says, you stupid little kid. I don't know, man. But this also confuses me that they started numbering the inductor from 5. Why is it L5? Should be L1. No? Or am I just asking for too much? And also, that may be a stupid question, but why are there 2 images? These are just 2 examples. Oh, okay, it's the same example, but top layer copper pores removed on the left, shown on the right. Copper pores, so these, like... How do you call them in KiCad? And I know you do them with B. Oops, something happened. How are you supposed to... Oh, it was this. Rule areas? Nah. Or was it? Rectangle? Now, how do I fill this? Okay, I don't know. I'm getting sidetracked again. The 2 high frequency and power are what? Okay, corresponds to this section 12.1, which is this. Okay. So it corresponds in the way that point 1 between the input cap and output cap when the MOSFET is closed, between the diode and the output cap when it's open. Both input and output cap need to be close to the IC. Yeah, that I know. I think I knew that. I don't know. But the question is, I think it's stupid to have the top layer to be ground, to be honest. Because all of these components are SMD, right? So each pin would have to have a via. That was via, I don't know, via, I think you pronounce it. That would be really stupid in my opinion. Because all of these pins are top or bottom layer, so they cannot be ground. They have to be mixed, I think. So that's an oversight. I'm glad I caught it now, to be honest. That would be so stupid, man. Let's say board setup. Layers. So this should probably be mixed. At least they would be all grounded. No, like the point is, my point initially was that if the PCB has ground planes on the outer layers, then if you put it on a metal table or it touches against a piece of metal like the phone chassis, then it would not short itself and die. That was my point. But that's stupid, because then you would have to place a via for each SMD pad. Less EMI, yeah, I know less EMI, but you know, it's just non-practical. Maybe then it means I need a 8-layer PCB. So that's stupid. Maybe that means I need something like that. I don't know, just my guess, you know. Cool idea, thank you, but we are screw but BQ. What do you mean? Screw but BQ, what does it mean? I also think it was a cool idea, but a little bit non-realistic. If we have emission, like radio problems, we can probably just put grounds like that. That would probably fix them. And that would be expensive. So I would probably do that only if there are emission problems. We'll see. We'll see. That's an easy fix because you just add 2 ground layers to the board. You know, so just in case, electromagnetic emissions. Six layers. Just noticed your system is suffocating from lack of RAM. I mean, it's 56%. What do you mean it's suffocating? It's all right. Sometimes it is a problem, like once or twice, or maybe 2-3 times. The stream crashed because I didn't have enough RAM. And I didn't notice and it just crashed. So that was stupid. 4 layers. So we have these 4 options. I'm gonna sleep on them and think. Maybe I'm gonna have some interesting ideas after I think about this. But this makes the most sense. This makes the most sense for me right now. How much RAM does this stuff use? You mean KiCad or what? Here's the entire like situation on my system right now. Oh, you don't see because of my camera. 1 second. Now you should see it. So I have 16 gigabytes and KiCad is using, it's not even on the list. Oh, KiCad is using 3%. I don't know why is it just That's weird. It's probably just using, I mean, I can search for it. Check this out. 3.2%. That's usually it takes up much more. I think it depends which tools you turn on, because if I turn on the schematics, it will probably jump up. Still not bad though, honestly. Sometimes it seems to take on more. I don't know what's the... Maybe if I load the 3D models, like, okay, who cares? Who cares? Who cares? I just need to change the layers to mixed now. Mixed makes sense in my opinion. Also, I have an idea. The mixed layer, I need to draw this for you. Let's say I have the PCB, right? And this is the top layer. This is the top layer. Let's say I have a line that causes a lot of emissions. Maybe that it's not that massive. Let's say I have one like that. And the line is in an inner layer. Okay, let's say it's layer 2, counting from the top. Then I can just, on the top layer, fill this area with ground. Like, I don't know, let's say these rectangles are ground pads or floods, or I don't know how you call them, just big pieces of ground that go over the signal line that's causing the emissions. And this way it covers it, but the ground layers don't take up the entire layer. Makes sense? So it's sandwiched, but only directly above and below it. Does it make sense, or did I explain myself clearly, or? Barely all chip will need some cap with line routed on top layer. It prevents sag and I think filter interference without regain some unwanted signal between cap and IC. You can also use vias as a Faraday cage. I think vias are a little bit more expensive, and I don't know how would you use vias to cover the trace in a situation like this. Maybe, I don't know. I think vias are just expensive and should be avoided if possible. It could cost less, yeah. Could cost less. By the way, guys, like the stream, please. Just give a like. Thank you. So that's a cool idea. I'm just gonna write that down. Ideas. Use ground zones or covers or floods to cover the put them next to the signal and connect the ground layers. Oh, like that. Yeah, but then I would have to have a ground layer on top, right? And I don't want that. Okay, that's the first idea. The second idea was to I don't know though, this might be one of those things where having pads is more expensive than the whole layer simply because it is an extra step. That makes sense. Having pads is more expensive than the whole layer. I don't know. I can just ask the manufacturer, to be honest. How will you add the smaller ground plane on a higher layer? Just add zones of ground. Makes sense to me. I don't know what's the like professional term for that, but just also I cannot really draw it because it's like PCB layers. I don't know how to draw that. I mean, I can try. Let's say I have layer 1, 2, 3, and I have a let's say signal trace here. No, let's say I have a signal trace like that. And it goes only from these 2 points. And let's say I have another one here. DC. AB. Okay, I'm stupid. Clearly, I don't know the D comes after C, not before it, but whatever. So these are signals, and they cause noise. So my idea is to just add ground only above them, like in certain layer zones or whatever. These would be grounds. Make sense, guys? Makes sense, makes sense. I don't think I can explain it any better. Maybe it's a super abstract and stupid idea, I don't know. Maybe it's something that exists and I just didn't invent it. Usually it's like that. You think you invent something and then it actually 55 people already did that. I think that's the way a lot of PCB are done. Exactly what I'm talking about. Are too much. 2 extra GND layers inside. Nice, 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 nice. Okay, now I feel good. My eyes. Let's do point number 1. Quest number 1. Place the sys output capacitor as close to sys and ground as possible. Okay, so let's locate. Okay, this is not the way, of course. I discovered gravity only to find out someone has already done that. It was a sad day. Have you access to a lab for EMI testing? I don't have, maybe. I'd have to ask my university. But that's not a big concern right now because EMI is only needed, as far as I know, for compliance with, you know, if I want to sell it. So that's not my main focus at the moment. Anyways, I think putting 2 layers of ground around the thing would solve it. Nice sentence, I know. Isn't it true that adding just 2 layers of ground as a sandwich would just solve all EMI emissions? Of course, except for the antenna and stuff that actually is supposed to do EMI emissions, right? I don't know. That's something I'll have to learn about and work with at some point. And let's focus here on the 0.1 cap. Place place the small one closer to the other. Closer than the other. Okay, so the small one should be the closest. Makes sense. Makes sense to me, but I know literally nothing. Okay. I also sometimes don't know nothing. But I've learned a lot already. Like, we're streaming for 2 hours and 20 minutes. I've already learned how to switch layers, change trace widths. What are the typical trace widths? I learned about layers. I think I got some ideas. Like, you know, learning. We're all learning here. Improving. Ground connections need to be tied to the IC ground with a short copper trace connection to ground plane. Okay. So here's the sys. And now I need to locate the capacitors. So this one should be the closest. And they're saying that it should be 0402. Can I ignore this? Like, I'm just gonna make more noise in this circuit, but I think it's not a problem because we have regulators later. So do I make sense or no sense? I don't like the fact that they are not like ordered. I guess they're ordered vertically here. 0201 will surely increase cost and will afraid dire. What is afraid dire? Like the whole idea with 0603 that we have currently is that you can do it by hand if you really want to. Change something and stuff. You know? 0201 is just, I don't know, impractical. Oh, this is massive. Okay, this may become a problem. Maybe it could be impossible to route even. Let's compare, because we have some 0402 components. This one specifically. These lyrics are so stupid. 0402 capacitor are kinda heat sensitive, but such a board is better cooked in a modified toaster oven. What? If you're talking about assembly, I plan to order it assembled. So I don't have to do anything in terms of assembly. Maybe connect the battery or something. So this is slightly smaller. I don't know if it's... Let's see one thing. Maybe I could make the courtyard smaller. The pink thing here. That would make some sense, maybe. I don't know, let's try. If I get into any problems, I will just solve them as I go, as usual. I'm overthinking this, probably. Also, if I do something like that, no one cares, probably. But let's not do that. Actually, if it's supposed to be as close as possible, I did a terrible job because I can just... Yeah, and the other stupid thing I'm doing is that this is the ground layer. Wait, but I changed it. Okay, My brain is overheating, man. Board setup. I changed it, but I didn't change the name. Mixed. Okay. A toaster oven can be used as a makeshift reflow oven. Hackaday have a few articles on this. It's better than hand soldering so many zero, of course. I mean, the hand soldering thing I was saying is not for making the board from scratch. It's rather if you want to modify the thresholds on something. For example, let's say I want to change this here to change the target current of the charger, for example. I can just remove this resistor and put in a different one, right? By hand. If it was 0201, I could never do that. Makes sense. I think it makes sense at least. What is this? This is a vibration motor. Okay, I'm gonna just bye-bye. I'll probably use a different one because this one is massive. It's fucking massive. Oh, wait a second. I want to see it in 3D view. Yeah, it's the largest component. So we could limit the usage of big part to those who might be change. I don't know what you mean, but yeah, just use big parts if possible. If possible. Also, probably nothing bad would happen, honestly, if I just used, let's say, only 2 capacitors instead of 5. Or this is 5, yeah. What do you think, chat? If I would use just 1 or 2, because these are just filtering capacitors, right? I don't think I need the power to be really filtered, you know, because as I said multiple times, it's going into regulators anyways. In the good old days, people put their dead Xbox 360 motherboard in the oven to reconnect the APU to board. That's funny. It's like putting inductor in parallel, ESL. What? What you mean? I'd like to, like, I'm not gonna do that because I value my time, but I would really like to make a board with and without filter capacitors and see how that would work. Just compare the 2 boards. That would be an interesting maybe video even. I don't know if I could make an entire video only on that. So these should also be as close as possible together. Understood. Understood. So So this is a... This should be here maybe. The silk screen. Let's just do this. 18, 19, 20, 19, 20, 21, 22. Paste. I don't know if that makes sense. Also, how do you like the mini silkscreen symbols in the footprints? Did you notice, like, the capacitors have little capacitor symbols here? That's just decoration, and maybe it makes it slightly easier to assemble, like less chance of, you know, making a mistake if you modify the board or something. That's annoying. Check this out. KiCad likes to do these kind of things, like they just fucking don't snap properly sometimes. Yeah, like where did that number come from? You should draw Clippy as a motherboard trace. Good idea. Good idea, good idea, good idea, good idea. Good one. We already have so many suggestions. The board is going to be just full of random PCB art and stuff. Interesting to see that this capacitor doesn't have, you know, maybe I have to update. What is going on? Why? I am confused. Why did it put all of these things here? I already have them. What have determined the number of capacitors? It's usually the ESR and ESL, but that much capacitors seem to need a really vast trace. I mean, that's the main power output, so it makes sense that we want a lot of capacitors, but do we really need to filter it that much? That's my thing I'm asking. The other thing I'm asking, why does it import these 2 times? Maybe like that. Oh, now it works. Yeah, I was doing that because I noticed the pads are not. Capacitors are not connected to ground. I'm working on it, okay? I was just dealing with some issue there. So just to remind myself, ground is in the middle. That's weird, but also I guess that's all right. Let's add via, okay. What's the shortcut? Is it V? I thought it was V. Control Shift X. So this is a mixed layer via like right here. Okay, so micro vias can go through only some layers. That's crazy. Just learned that. Crazy. That's cool. That's really cool. That's really, really, really cool. Now, how do I use it to connect to ground? I should probably just do this. Control Shift V. Nope. Control Shift X. Okay, so this is a ground via. Is it via or via? I don't know how to do this, honestly. Is it? Okay, this maybe is going to be stupid, okay? I don't know how to do vias, okay? Don't scream at me, please. Because I've never done this in a 6-layer board. Okay, I think I know. I know. I just figured it out. Let's first start off by connecting this. Nice. And now... Huh. Nah, I don't know. I think I knew, but I don't know. Maybe it doesn't want to connect because it doesn't... You know what? I have no clue. I think I need to just take my time, read about this, and come back to this later. This is like, there's no point in guessing right now. I'm guessing the problem is that KiCad doesn't understand this should be ground. And it thinks this should be, you know, backlight minus, which is not even connected to ground, I think. Let's check the screen to see that. Yeah, here's... Oh, maybe this is a problem? What if I remove this? Now it's ground, and now it doesn't work. That's confusing. I don't know. No idea, honestly. I am confusion. So yeah, I think, dear chat, we did what we wanted to do. Because via has been made before correction. Yeah, I'm not gonna understand that right now, probably. I'm too tired, I think. So, gentlemen, the goal has been achieved. I did lay down useful traces. That was the goal of the stream, and it's achieved. First day of university this year? Yeah, for me it was the first day. Let's just save the changes. Yeah, we also added the new model and stuff, so that's also important. This and this, right? Add correct charger footprint and step file. You've been at uni for almost a month now. Yeah, my friends who had to like retake exams also were there for like a month already, because you know, so it depends what you have to do, right? We smell your brain burning from Montreal. It's crazy. Yeah. I'm also getting hungry, so that's probably a contributing factor. Okay, let me just stage all of this. And let's say set up layers. I think that's it. And these two I can just remove. That's why there's the big smoke out. Yeah. So these two I just remove with Shift X, very useful shortcut here. It restores to the state without these files. So effectively it removes them, and I just push now. Yay! Nice. Nice. That's cool, I'm happy. Big progress. Big progress and lots of cool stuff to learn in the near future. So yeah, that's a small step, but it's, you know, even the longest journeys start with the first step. Right, so yeah, gentlemen, you know, it's time to say the words. It's time to say the words. Thank you for watching. I hope you come back for the next stream. I appreciate you very much. Thank you for your support. Check out the links in the description. I think I fixed text-to-speech tipping page. So it's now like you can tip, I think. Thank you for your help. And, check out my Patreon, join our Discord, contribute to the project if you want. If you have any questions, ask on Discord. You can text me anytime you want. I usually respond pretty quick. I don't know, man. Bonne soirée, Mr. John Diode. Thank you for your company. I hope you enjoyed. You can give me some feedback in the comments if you want. Like, comments are always welcome. I also stream on Twitch if you want to join there. So, bye bye.